everybody. So we are at Module 11. We're getting closer to the end of the year. And today we're going to be talking about something called phototropism, which just basically means that plants like to grow to the light. So I brought back our plant that we did last week where we covered the leaf, remember? And we talked about photosynthesis. And plants need a few things to make their own food. Do you guys remember what they are there?
Light, air, water, and nutrients.
Okay, so they do need light, and they need water, and they need carbon dioxide, and the energy from the sun. So last week, when we were talking about photosynthesis and chlorophyll, we covered this leaf. We covered it with black paper. Why did we do that?
To extract the chlorophyll.
Well, not to extract it. We did extract the chlorophyll. Oh, and we still have that white leaf. Can you run over there and grab the white leaf over there? We did it to cover up the light so that the chlorophyll would be used up and the plant leaf would be a little bit lighter, right? So Ignatius, do you want to carefully take that off and see? We're going to check. Marita's going to come in here and look and see if the leaf got any lighter. So here's a comparison. Here's one of the darker leaves, and that's the leaf. This one right here is the one that was underneath the black paper. So what's happening is the chlorophyll is being used up for the plant, and since it could not receive any light because the paper was on top of it, then it had to start using up its chlorophyll in order to make energy. So as it used it up, the leaf got lighter, and we can compare it to this darker leaf. If we leave this on for a week, it would probably continue to get lighter, as light as this one. And this is our leaf from last week where we extracted the chlorophyll with on the stove with the isopropyl alcohol. And now we can compare those two to see this is a leaf without chlorophyll and this is the one with chlorophyll. And so today we're going to go ahead, and it's really cool. Since the plant needs light, it's been created so that it searches out light. Really cool. So Marita's going to come from behind me, and I would like you guys to, if you have a piece of paper, you can write along with me. These guys have a science notebook that they're going to use. So today we're going to talk about phototropism, and I'm going to write that word. I'm actually going to use a darker marker so you can see it better. So phototropism, and you guys can write it. It's P-H-O-T-O. That part is photo, and then tropism. T-R-O-P-I-S-M. And that's just another one of those big words that we're learning in science this year. And phototropism actually comes from a Greek word. The Greek photo means, can you guys guess what photo might mean? Think about like photograph.
Picture.
Close. What do you need if you're taking pictures? You need what?
Camera.
You need a camera, but what does a camera need to work? Can your camera work at night in the complete dark?
Needs light.
It needs light. Right. So photo means light, and tropism comes from another Greek word. You guys, can you have any idea what tropism might be? We're talking about, it means to turn. Tropism means to turn. So this big word, all it means is to turn towards the light. The plants need to turn to the light because they were made, if they need light to make their own food, then there's a special way that they were made so that they would turn to the light. And I'm going to explain that. I'm going to draw a little picture. So we're going to move this one aside. How shall I use the back? So this is really cool. You can take on your piece of paper, if you're writing along with us, you can draw a big, let's do a sun. That's going to be our source of light. Now plants, it doesn't always have to be the sun that it turns to. The plants can turn to a light bulb or even a flashlight. Any sorts of light the plants are going to want to turn to. So do you guys have a sun drawn? Cool. All right, so then we're going to draw a plant. We're going to draw a flower. So your flower needs a stem. And because here's the light, what happens is as that flower begins to grow, it's going to start curving towards the light, like that. So if you're drawing along with me, draw your stem and your leaves, and then curve that right on over to the sun. And then I think I'm going to make this a bright red flower. So we're just going to put the flower on the top of it. So here's this light source, and here's the plant turning towards the sun. Now here's the really cool thing. This is how this works. On this part of the sun, so Ignatius and Mateus, which part of this would be the dark side of the flower? Can you point to it, Mateus?
The dark side?
Yeah, which part of the flower would be in the shade? Yeah, on this side. This whole side right here would be the dark side of the flower. And in this part right here, on these cells, let's use a brown one. On this outside right here, on the dark side, inside the cells right here is something called auxin, which is AUXIN. And on the dark side of the plant, this is really neat. When it's dark, the auxin accumulates over here. And auxin makes, so normally the plant cells in the stem would be like this. But when they get a lot of auxin in them, they stretch out, they get longer, kind of like a rubber band when you pull on it. And so the auxin makes them get longer on the outside of the stem. So let's draw the stem. Where did my glue go? We're going to draw the stem right here so you know where it's at. They start to get longer on the outside, but the plant cells on the inside are still their normal side. So it's like it's being, like if this is the plant, it's like this side is getting longer and getting pulled toward the light because all of these cells are getting stretched, but these are staying the same. The really cool thing is that all of the plants, that it can change. So if the sun, if we turn this plant around, if we get our sun back out, and we take and we turn that plant around, then the auxin, if we turned it away and put the flower facing away from the sun, and we'll draw our stem, then what would happen is this side of the plant, which is now, this side would now be in the dark, and then those cells that were small, they would start to get longer like this, and then what would happen, Benedict or Mateus? Or
It would turn towards the sun.
right, it would start to turn towards the light, and then that red flower would be starting to turn. And maybe you guys have noticed that before. If you've ever seen like sunflowers that change, they actually move throughout the day. The sunflowers in the morning might be facing this way, and then throughout the day they track the sun in the sky and they actually move. So that's what phototropism is. And I want to show you a couple of plants that I've had sitting in the sun here in our kitchen. And I want to see if you guys can guess which way they were facing. So we'll start with this one. All right, Mateus, which way do you think this was facing? This is, can you see the window? That's where our sun was coming in. Do you guys think that the plant was facing this way? That would be the first way? Or do you think it was facing this way? What do you guys think?
The second way.
The second way. And how can you tell that?
Because the leaves are a lot lighter.
Well, the leaves,
And
which way
also
is it going?
Growing that way.
Yeah, you can see that the plants are trying to get to the light. So for the last week, this plant was sitting like this in my kitchen, and those leaves were trying to seek out the light. The same thing, let's try this one. We have this one in the kitchen. This one's a little bit harder to tell. Which way do you think this one was facing? I'm just turning it around slowly. Do you know, Mateus?
This way.
Yeah, it was facing this way. These ones were starting to turn towards the light. And then I have one more. You guys think this one was this way
Yep.
or this way?
First way. First way.
It was definitely the first way. They're all starting to turn. So on this part of the plant, I'm going to bring it down here. On this side of the plant, the dark side, that's where the auxin was accumulating, and those plant cells were getting really long, but these ones on the inside were staying little. So it was like it was being stretched to pull this way towards the light. So that is called phototropism, and we're going to do an experiment about that. That's really cool. So you can click on the box below and you can check out our experiment for this week. Thank you.